Hi students, it's Professor Gina, and this video is going to be looking at example problems for section 7.4. A lot of these examples are calculator based, and so I'm going to skip the calculator portions, but if you have questions about how to use your calculator, you should join me during our Zoom office hours meetings so I can look at your calculator and tell you how to find the specific buttons. What we're doing in this section is we're actually working backwards. We are given information about a trig function and we're asked to tell what the angle is that's associated with that trig value. So for our first example, we'll look at cosine inverse of 1/2. That little -1 that's up in the as an exponent here means the inverse function. And so what we're given is a trig value, and we're asked to give back the angle that's associated with that. So it's asking us, what angle has a cosine of 1/2? And so we could look at the unit circle, or we could just plug this into our calculator as it is, and the calculator will tell us that the answer is 60 degrees if you're in degree mode, or pi/3 if you're in radian mode. So that'll be our answers for this first problem. The second example will be similar, another calculator question. Tangent inverse of √3/3. Now, if we were to think about the unit circle, there are actually two different locations where the tangent is equal to √3/3. One of them shows up at 30 degrees over here, and this is the one that the calculator will give you. And the other one shows up over here at 210 degrees. The calculator won't give you this second answer of 210 degrees. I'm bringing it up because in the next section, in section 7.5, when we're solving equations, we actually want to give any answer that is valid, not just the ones that are given on the calculator. So in the next section, we'll actually need both of these answers. So that's just something to keep in mind. But again, plugging this into the calculator, we're going to get either 30 degrees for our answer if you're in degree mode, or pi/6 if you're in radian mode. Now, the third example is a little bit different because it calls up a button that doesn't exist on the calculator. We don't have a secant button on the calculator. So we're asking ourselves, what angle has a secant of √2? Another way of writing this is the secant of some angle is equal to the √2. Translating that into the reciprocal function, into cosine, we know that the cosine of that same angle is the reciprocal 1/the √2. So then if we change this back into inverse functions, we will take cosine inverse of 1/√2, and the calculator should give us back the angle. So this is what we'll plug into the calculator. And the calculator is going to tell us that the answer is either 45 degrees or pi/4. I think I didn't highlight our answers back up here for number 2. So these are all examples of angles that we see on the unit circle. The next couple examples are ones that are not on the unit circle because they're numbers that don't fall on the standard ones that we typically memorize. So let's look at cosine inverse of -0.2935. This is asking us, what angle has a cosine of -2.935? We can just plug this straight into the calculator. And the calculator will tell us approximately, oops, 107.1 degrees. That's if you're in degree mode, or 1.8687 if you're in radian mode. This is in radians. Remember that if you don't have the degree symbol, it's implied that it's radians. You don't have to write the radians, but I'm just writing it to kind of remind you. Let's look at tangent inverse of 158. We'll just plug that straight into the calculator. And the calculator will tell us that it is approximately 89.6 degrees, or 1.5645 radians. For the next example, we're looking at the secant inverse of 1.1677. This is asking us what angle has a secant of 1.1667. Similar to one we had just a minute ago. They're asking us for the angle, and this is the value of the secant. Rewriting this, it's asking us, it's saying the secant of some angle x is equal to 1.1677. That means that the cosine of the same angle is 1 over that value. So what we'll do is we'll plug into the calculator cosine inverse of 1 over 1.1677. So this is what we'll plug into the calculator. And the calculator is going to tell us that in degrees, it is approximately 31.1 degrees, or 0.5426 radians. I'm going to pause for just a second. I'm going to go back and number all of these so it'll be easier for you to read when you are going back to look at them. Okay, I'm back. I just wanted to go back and make sure that I numbered all of the problems so you could tell the difference between them. So now we're on problem number 7. This is similar to the one that I was just looking at. This is asking us to take the find cotan inverse of 1.265. It's asking us what angle has a cotangent of 1.265. So if we rewrite this into a different format, we have that the cotangent of some angle x is equal to 1.265. That means that the tangent of that angle is 1 over that value. So in the calculator, we'll enter tangent inverse 1 over 1.265, and that'll give us back the angle. So entering into this into the calculator is going to tell us that x is approximately 38.3 degrees, or 0.6689 radian. Okay. For our next example, we're looking at one that the calculator doesn't give us actually the answer that we need to provide. So let's do cotangent again. Cotangent inverse of negative root 3 over 3. And if you plug this into the calculator, the calculator will tell you that the answer is negative 60 degrees. But when we look at what the range for cotangent inverse is, it is between 0 and pi. In the slides, there are a couple of pictures that show you that when we take the inverse function of something and we're reflecting it across the line x equals y, we have to restrict the domain, which ends up restricting the range of values so that our inverse function meets the criteria of passing the vertical line test and remains a function. And for that reason, we have these smaller range values for all of the inverse functions. So we will only accept values that are between 0 and pi for this particular function. Negative 60 degrees is not in that range. This is between 0 degrees and 180 degrees, right? So what we do is a little bit of analysis. We think about the fact that negative 60 degrees is about here. And for cotangent, the other place that will show up, remember that the period, we know this from our graphing, of cotangent is pi. So the values will repeat every 180 degrees. So there's going to be another iteration of the same value over here at 120 degrees. And this 120 degree value falls within the range that we're looking for between 0 and pi. So this is actually the answer that we want, not the one specifically the calculator gave us. So in this case, for our original cotangent inverse of negative root 3 over 3, the answer that we're going to provide is 120 degrees or 2 pi over 3. We have to make sure that the final answer that we're giving is within the range of the acceptable values for that particular function. Okay. The next set of examples are taking a function, a trig function, and an inverse function in combination. So these are going to be slightly different. Again, some of these can be entered in the calculator, some of them we need to do a little bit more analysis of. So this is number 9, I think. Let's take the tangent of tangent inverse, negative 4.2. So I have a value of the tangent. This is asking us what angle has a tangent of negative 4.2. And then the larger question is asking us, what is the tangent of that angle? So what's effectively happening is that tangent and tangent inverse are sort of nullifying each other. It would be the same as if you took the square root of 5 squared. The square root symbol and the square are going to cross each other out because they're inverse functions. And though even if you plug this into the calculator, you will get negative 4.2 as your answer. And that kind of makes sense based on what we're seeing here in the analysis. For the next problem, sine inverse sine of 2 pi over 3. We can look at this part that's in parentheses, and we know that the sine of 2 pi over 3 is square root of 3 over 2. So now we're asking ourselves, what angle has square root of 3 over 2 as its sine. And the range for sine inverse is negative pi over 2 to pi over 2. That's based on restricting the function so that it falls within a space that would work with the vertical line test. So for the sine function, we're only going to consider this area from negative pi over 2 to positive pi over 2. And 2 pi over 3 doesn't fall within that section. What does fall within that section is pi over 3, which is here. Pi over 3 is here. 2 pi over 3 is here. They both have the same sine value. The sine value is the y value, right? They're both the same. But the answer that we have to give is pi over 3 because it falls within the given range for sine inverse. So for this problem up here, we're going to say that our answer is pi over 3. For number 11, we're looking at cosine of sine inverse root 3 over 2. So this is asking us, what angle has root 3 over 2 as its sine? That's similar to the one that's the same as what we just did, and so we know that that's going to end up being cosine of pi over 3, right? And the cosine of pi over 3 is going to be 1/2 for our answer. All right. The next couple of examples are ones that we have to do by drawing pictures, and the calculator won't help us in this particular regard. We want to find the tangent of cosine inverse of 3 over x. So cosine inverse is an angle. We don't know what that angle is. So what we do is we draw a picture to denote what is given to us. We're going to draw a picture here in the first quadrant. We don't know what the angle is. Let's call it theta. We know that cosine of theta is the adjacent side over the hypotenuse. So we'll say that the adjacent side to the angle is 3, and we'll say that the hypotenuse is x. We're being asked to find the tangent of this angle, and tangent is opposite over adjacent, right? So we need to figure out what the value is over here of this opposite side. So we'll use the Pythagorean theorem. We know that 3 squared plus star squared is equal to x squared. So 9 plus star squared is equal to x squared. Star squared is equal to x squared minus 9. And then taking the square root of both sides, we get that that opposite side is the square root of x squared minus 9. So this is the square root of x squared minus 9. Now we can use that information to figure out the tangent. The tangent of the angle, which we don't know the value of, is the opposite side square root of x squared minus 9 over the adjacent side, which is 3. And this is our answer. All right, final problem for this section, number 13. We're being asked to find the sine of cosine inverse of x. What's given to us in this first set of parentheses is an angle. We don't know what the angle is, but we know that the cosine of that angle is x, or x over 1. So similar to the problem we just had, we'll draw a picture. The only difference is we don't know if x is positive or negative. It could be either. So we've got to take a couple different options into account. So in my picture, I'm going to account for cosine being positive, which would be in the first quadrant, or cosine being negative, which would be in the second quadrant. We're saying that the cosine, which is the adjacent side over the hypotenuse, so it'll be x over 1. We're assuming that the hypotenuse is 1 in both of these examples. I don't like that this triangle is so much smaller than the other, so I'm going to redraw it. That's better. Okay. Just like the problem that we had before, we'll use the Pythagorean theorem to find the missing side. Let's call it y. So we have x squared plus y squared equals 1 squared. Y squared is 1 minus x squared, and y is the square root of 1 minus x squared. The good thing is that this is going to be true in either of the pictures that we've drawn. And so either side is going to have the same value. So the sine of one of these angles, we don't know which one it is going to be the opposite side over the hypotenuse, or 1 minus x squared, square root of that, over 1, or just square root of 1 minus x squared. Okay, those are the problems for section 7.4, and then I will make another video for section 7.5. Thanks for watching.